Here we are in 10.5 with comparison tests, plural. We're going to have two. We have a comparison test and we have a limit comparison test. Similar, but different. So let's start. This first video is just going to be about the comparison test. I mean, we may only have 2 videos in this, maybe 3, where I'm going to show you the comparison test. I'm going to show you the limit comparison test. Then you're going to get practice so you can start to understand it more, because I can do 50 problems or I can do 3. It's not going to help much unless you get on into it. All right. And here's our comparison test. And you've seen this before in Chapter 8 when we did our improper integrals. Hopefully I yelled and screamed about it enough saying, you're going to need this later. A comparison test. We can say that, hey, let's say we got 2 sums. So one with A, one with B. Well, if A sub k is smaller than or equal to B sub k, and the bigger one actually converges. You know what I mean? So we're looking on like a graph and we're like, we have B. It's always bigger. And then we have A. It's always smaller. And our B goes towards a limit. Wouldn't the smaller thing also have to converge? So something that's bigger goes to a number. Wouldn't something smaller also have to go to a number? We're only dealing with positive stuff. It's not going to negative infinity. It's bounded. We're saying it can't go above this. That's what the first piece says. And it's real easy to get this stuff backwards. Now next we say, all right, now let's assume that B sub k is the smaller one. Or equal. Or equal. Then if the smaller one blows up to infinity, the smaller one, B sub k is the smaller one now, and it goes up to infinity. And then we have some A sub k that's even bigger. Well, come on, man. If the smaller one blows up to infinity, the bigger one has to as well. That's the logic of it. There's not much more than that. It's just a little bit of a logic game. This isn't even... It's not even math. This is just logic. But a lot of times it's tough to use logic when you're doing all this math. You know, it's kind of rough. So let's see what we mean by this. And let's check this one out. Let's see if this converges or diverges. So we're going to say from k is equal to 1 up to infinity. And we're going to say k cubed over 2k to the 4th minus 1. Now, the way it sits, I don't have a tactic. I don't know what to do. I mean, shoot. Actually, I could totally do this problem. It has to diverge, doesn't it? It's got to diverge. I'd look at this and be like, power 1 bigger, power 1, or power 1 smaller, power 1 bigger. That looks like with P series, we could just say it diverges, but yeah, whatever. We can't necessarily say that. So what I want to do is take out what's inside the sum and go, well, wait a second. Let's compare it to something. Wouldn't it be dope if this minus 1 was gone? Wouldn't that be great if that minus 1 was gone? We could just like simplify that thing down, have ourselves an answer. That would be sweet. So when you subtract 1 in a denominator, all right, so I'm saying 1 has a minus 1. The other one does not. Which one's bigger? Which one's bigger? When the numerator is larger, you have a smaller number. So what we could actually say is be like, well, hold up, dude, hold up. This is less than k cubed over 2k to the 4th. So if we could show that if the smaller one diverges, then the bigger one has to diverge as well. Diverges as well. So what we'll do instead is we're just going to go like, it's like similar. It's not the same. So we just broke it down like that. But technically, I don't even want to write it like that. I don't even want to write it like that. I don't even want to write it at all. I'd actually, yeah, that's good. That's good. I'm just gonna do this and go, well, hey dude, this one's smaller then. I'm gonna write it in this way. And then this is equal, what is that? The sum is k is equal to 1 up to infinity of 1 over 2 times k to the first, which diverges by p-series. Thus, the sum is k equals 1 up to infinity of k cubed over 2k to the fourth minus 1 also diverges by the comparison test. CT. Oh, when you take your test, your exam, you're going to need to know all of your different rules. I like to play a game where I give you a bunch of problems and you're only allowed to use one test one time. Makes the problems a little bit simpler, but makes you have to think about all your different tests. So there is a first example of a comparison test. We found something that was smaller that we could evaluate. We found out that the smaller thing diverges, goes to infinity. Therefore, something bigger must also go to infinity. And there we are. Let's go to one more. And let's look at this. Let's look at, let's do the sum. Is k equals, let's go to 2 to infinity. What do we want to do? No, 2. ln of k over, let's make it k cubed. Well, what you gonna do, buddy? What you gonna do? How are we gonna do this? Well, I think it's the ln of k we want to look at. And I want to claim that ln of k is bigger than k. No, that's not true. I believe ln of k is greater than k. Or ln of k is less than k. When k is, greater than or equal to 2. You ever seen ln of k? You ever seen an ln function? Goes like this, through 1. And then let's draw k. Yeah, I'm pretty sure k is a little bigger. You know what I mean? So what I'd like to say on this is like, whoa. Hold up. ln of k over k cubed, well, that's less than k over k cubed, which is just 1 over k squared. So we found something larger. It's larger than this. So if we can show that something larger converges, well, then the smaller one has to converge as well. This is logic. So we're like, okay, well, hold up. This next term is actually bigger. And I want to replace it with the 1 over k squared. Well, this converges by the p-series. And since the larger one converges, the smaller one must also converge. Therefore, the sum, of being super fancy, k equals 2 up to infinity of ln of k over k cubed converges by the comparison test. That's our game. That is our game. So if you can find something that's smaller and it diverges, well, the bigger one must diverge, your original. If you can find something bigger than what you started with, and that converges, well, then your original will also converge. Do you see how that's easy to get backwards? I know for me, I got it backwards a couple of times. But it's a logic game. It's just a logic game. All right. Good luck. We'll be back for our limit comparison test, and I think that'll wrap it up. See ya.